All right, for this problem, we're asked to solve this equation, cosecant of theta plus cotangent of theta plus 2 equals 1. And we're asked to solve for all values of theta that are between 0 and 2 pi, not including 2 pi. So the first thing we can do here, let's go ahead and get that 2 over to the other side. So this is going to be cosecant theta plus cotangent theta. If we subtract 2 from both sides, this is going to be equals -1. All right, now we've got a cosecant and a cotangent. So we need to have the same trig function for both of these. So we'd like to use a trig identity to turn one into the other. But we don't have a nice trig identity for cosecant and cotangent. We do have one for cosecant squared and cotangent squared. So what I'd like to do is square both sides of this equation. Let's first get the cotangent over to the other side. So we get cosecant theta. If we subtract cotangent from both sides, we get equals -1 minus cotangent theta. And now let's square both sides. So we'll get a cosecant squared and a cotangent squared. Those, then we can use those. We use our Pythagorean identity, 1 plus cotangent squared equals cosecant squared, to get these to be the same trig function. So if we square both sides, we get cosecant squared is equal to all of this squared. So -1 minus cotangent theta squared, and I'm going to write that as times -1 minus cotangent theta. And now we can FOIL this. So we get cosecant squared is equal to -1 times -1 is 1. -1 times cotangent theta is positive cotangent theta. We get the same thing on the inside, so this is going to be plus 2 cotangent theta. And then negative cotangent theta times negative cotangent theta is positive cotangent squared theta. Now we've got a cosecant squared, and we know that cosecant squared is equal to 1 plus cotangent squared. So we can replace this cosecant squared with 1 plus cotangent squared. Now everything's in terms of cotangent. And now if we subtract cotangent from both sides, these are going to go away. Both of those are going to subtract to 0. And the same thing is going to happen if we subtract 1 from both sides. We're going to get 0 is equal to 2 cotangent of theta. And if we divide both sides by 2, we get that cotangent of theta is equal to 0. That should be a 0. Cotangent of theta is equal to 0. So now we need to look on our unit circle and see where, for what values of theta, is cotangent of theta going to be equal to 0. Well, cotangent isn't on our unit circle, but remember cotangent is cosine over sine. So we need to look for where is cosine going to be 0. Because if cosine 0, then we have 0 over whatever sine is, and so that's going to be equal to 0. So cosine is equal to 0 at pi over 2 and at 3 pi over 2. So we get theta is equal to pi over 2 or 3 pi over 2. Now, remember that whenever we square both sides of an equation, we need to go back and check to make sure that the solutions that we found are legitimate solutions. Because sometimes when we square both sides of an equation, we end up introducing extraneous solutions. So let's go back and plug in pi over 2 in our original equation up here. So the cosecant of pi over 2, well, cosecant's 1 over sine. Sine of pi over 2 is 1, so the cosecant is also going to be 1. So that would be 1. Cotangent of pi over 2, well, that's cosine over sine, so that's going to be 0. So 1 plus 0 plus 2 is equal to 1. Well, that doesn't work. That's not true, that 1 plus 0 plus 2 is equal to 1. So we're going to reject that solution. Let's try 3 pi over 2. So the cosecant of 3 pi over 2, well, sine of 3 pi over 2 is negative 1, so the cosecant would also be negative 1. The cotangent is going to be 0. Plus 2 is equal to 1. So negative 1 plus 0 plus 2, that does equal 1. So this 3 pi over 2 is going to be our solution.